We previously wrote the definite integral in the form of an accumulation function. So for a continuous function on an interval that contains a, then the area under the curve of that function is equal to the accumulation of change. So effectively, capital F is an antiderivative of the function f. So in a similar way, for a continuous function on the interval from a to b, the area under the curve of the function in that interval can be written using a definite integral. And that's equal to the change in the antiderivative. So effectively, evaluating this integral is the same as taking the difference in the antiderivative evaluated at a and b. And that's a fundamental theorem of calculus applied to definite integrals.